In this tutorial, we will cover downloading and installing KUKA PRC, and we will set up a Grasshopper template for future KUKA PRC simulations. Alright, to begin, let's navigate to the KUKA PRC Food for Rhino page. So I have a Google search engine already showing, and I will type in KUKA PRC Grasshopper download. Alright. From here, we will go to the Food for Rhino page. We have to sign in first, so I will sign in with my Food for Rhino account. And from here, we will download the newest release. I'm going to navigate to our KUKA PRC folder. And we will let it download. From here, we can open and execute the file, which will set the user agreement. We can run through this, set the place where we want it to download and install, and install it. I already have this installed, but let's see what happens. We will need to close Rhino first. So let's close this out. Alright, once that installs, we can open up Rhino. Once that installs, we can go ahead and put in our MIT license file. So while Grasshopper loads, let's go ahead and download our MIT license file. So, alright, once our Rhino has loaded, we can open Grasshopper. To begin, we want to verify that our KUKA PRC is working. So I will type in KUKA PRC core and open the KUKA PRC settings. From here, we can see that everything is up and running. In this component, we will basically control all of our simulation for the KUKA. The next thing we need to do is to install a KUKA PRC license. So make sure you had downloaded the KUKA PRC license file and stored it in a folder that you have access to. To install, we're just going to click install. We're going to navigate to our KUKA PRC license file. From here, we can open it to make sure KUKA PRC has our license. So it will give us this generic pop-up. The license has been successfully copied. Make sure you restart your base software for the new license to take effect. So let's do that. Let's close out everything. We're going to hit apply just to be safe. Exit out. We don't need to worry about this unnamed Grasshopper file. So we'll close out Rhino and let it restart. Alright, let's open up Rhino again. Alright, now we will cover our basic Grasshopper template setup. So we're going to open Grasshopper. And basically begin our new file. So everything for KUKA PRC runs through the core component. So let's just drop that in here and leave it off to the side because for right now, we will leave it alone while we set up our working cell geometry. So the next step is to load our rhinoceros working cell geometry. So in Rhino, we're going to open the working cell for our KUKA. We'll navigate to where I've saved the file, and we have the Rapid Prototyping Lab cell geometry. Just going to open that up. I'm going to move my Grasshopper out the way. So as you can see, it comes with a view of the KUKA cell. So this will help us place our real-world objects and run our simulations accurately. We only need this closed curve at the moment, and the next thing we will need to do is to import this into Grasshopper. So we can grab all of this. We're going to, in Grasshopper, select just a basic geometry component. We're going to set multiple geometries, and now we have all that mapped into Grasshopper. Let it compute, and we're back. So bring back up Grasshopper. We do not need to preview this at the moment, so we will set it off to the side. The next thing we need to do is to set up our base. So to do this in Grasshopper, we will take a frame component. So we're going to type in KUKA PRC frame. Actually, we're just going to type in frame and see. Oh, here it is. We're going to get our frame. So from here, we can set our KUKA PRC base. So in order to map this to our core component, we need to add a base input. So we're going to right click and click Set Base System through Grasshopper. Alright, so now we can map our base plane to our frame plane. So from this plane, we're going to automatically set it. It's going to give us red because we haven't inputted any of these values. So in KUKA PRC, and when using the KUKA, we always need to set our base frame number. For the tutorials I will be using, we will use frame number 21. Automatically get a number slider right, and we need to set up our frame XYZ and ABC coordinates. So from your base calibration, you will pull out these points, map it onto either a slider or a panel or any numeric input, and map it into these components, which I will do now. Now we need to enter our ABC values, which are also important. So we can always duplicate this and type in 0.005. That's our A. Our B, also small, is negative 0.002. Enter, slide that into B, duplicate it again, and then we will put negative 0.004. Slide that into C. We can group it, call it ABC value. Okay, so now we have our base and we have it going to our KUKA PRC. Now it's going to be read until we have a simulation component, command component, a tool component, and specify a robot. So we'll wait to do all those things. Let's first navigate to setting up our origin. So automatically our working cell geometry is set up so it reflects the actual origin. So we were to hide all this, our working cell isn't actually positioned at this origin. So I'll type in the show command, bring it back, type in grasshopper. Alright, so we need also to have this point visible in grasshopper, because once we set this base, it will shift our entire working cell to that origin point, where the origin we specified as our base becomes that world XYZ 0.0.0 coordinate. This will make sense once we set it up. So let's go ahead and get a point going. I'm going to type in construct point. I'm going to give it the same number, 0, which reflects the world origin. We also need another point that reflects the KUKA origin, which is mapped to these XYZ coordinates. So we will slide this here. And we can label it. So instead of point, we'll type in world point. And this one we'll type in KUKA base or KUKA origin, just to be clear. So if somebody else were to come along and see our actual setup, they will understand what is going on. Alright, next step is to create a vector 2 point to actually move this working cell geometry. We can name it working cell and actually have it accurately reflect the world origin. So we will actually know where to put our geometry without having to think too much about it. Alright, so we'll do a vector 2 point. Very easy way to move things, or get a vector to actually move things. So slide those into each other, and then we can actually visualize this vector to see what it's actually doing. So if I type in vector visualization, or vector display, we can take this vector and we can actually see how it will actually move based on our Rhino base origin. So in the real world, we can see how it's actually going to move to reflect the real world origin. Oh, I do that. We also need to have some extra geometry. It's on the laminate tape. So we can remove the tools. We will get into that at another time. And this also needs to reflect our actual geometry. So this zoom out. So we can always clear this, clear these values. We just need this. Now everything else we had in there, like that tool mount and those extra curves, we're going to set it again, and hopefully it doesn't think too hard this time. Excellent. Okay, so now we have a way to actually translate this geometry. So from here we can pull a translation vector, which is what we have, but let's make another component just to visualize it. We'll call it translation vector. And from here we can actually move our geometry. So let's go ahead and make a move command. We have our translation vector, we can throw that. We also have our working cell, which accurately reflects our robot from the world origin 000. We can move it. And now let it compute. We have this actually showing in Rhino. Let's turn the preview off, and let's actually make a custom preview. Right, and then we need a swatch color. Let's make it something purple. Give it the swatch color. Give it the geometry. Now we can preview our move geometry, and we can actually hide our cell. So put default back on as our working layer, turn that off, and we deselect. We now have our cell. It's purple. It's in Grasshopper, and we can move it parametrically if need be. Last but not least, we can go ahead and give KUKA PRC the necessary components for it to turn off from red to an orange. So first we need to give the simulation slider, or the simulation input, a slider input. So we just type in a slider component, and automatically gives us what we need. We just need something from 0 to 1 with floating point parameters. So give that to that. We also need some type of command for it to do. So what I would do is give it a access command. Access command automatically comes with default set in place. We'll throw that into our command component. We do not need a tool just for now, but we do need a robot. So our robot is the KUKA. Actually, let's go to our top. So we have the KUKA PRC display, and we have a whole bunch of robots. We can basically give it any robot, but we need the robot we actually have in the RPL. So typically we'll do the KUKA Agilis 900, which is ours. Drag that down here. We don't need to put anything else. We just need to throw it into the KUKA PRC core. And now, instead of it being red, we have a working file, and we can actually see that we have a robot in place. So if we minimize this, it's a robot with a imaginary tool that actually gives us our tool coordinates. It's out to the side. I'm gonna click off so we can actually see. And so from here, we can manipulate the number slider to show the axis movement we inserted into the core. Oh, turns out, let me put the frame. No. So as you can see, we didn't actually map the robot to the cell, which we had moved, and we need to move this frame into the core instead of the actual base. So let's disconnect this. Disconnect this frame, the word base into the frame component. And as you can see, it now maps accurately to the cell, and we now have an accurate representation of how the robot will move, which is pretty cool. So also will allow us to see our actual base. So we turn on this world point. Oh, it's actually hidden underneath. We can turn off our display, actual preview, disconnect it. Oh, actually, turn off our preview. Bam. We can now see that our actual origin, our world origin, is now our KUKA origin. So if we want to actually, if we map where our KUKA origin is in the real world, we know where to actually set up our file in the Grasshopper environment. So let's turn back on custom preview. It's right there. One thing we can do is now group all this together. We can put this in a group called working cell. So one thing we can do is manipulate our working cell environment so we have a little bit more tolerance to play with when moving our objects in the physical world. So what we will do is deconstruct our translation vector. We're going to deconstruct it. And we're actually going to hit construct vector. Construct our vector x, y, z. Okay. And then let's move this down. And now we can have a little bit more freedom. All right, we're going to map our x to our x, y to our y, and then we can do an addition component where we can adjust the x, well, where we can adjust the z offset. I'm going to plug our z to a. We can slide our r into the vector. What we want to do is add a number slider. So let's say we always want to do it in the positive direction, but we'll actually allow with some negative direction as well. So we'll type in negative 100. It's less than 0, which is less than positive 250, just to be safe. All right, plug that in. So now we can actually remove this translation vector for our geometry. Automatically, we're going to set it at 0, but if we want to actually lower it, we can raise it, we can. So if I want to raise this to 10, I can raise it to 10. We're going to slide this, or disconnect this translation vector out, put this offset translation vector in. Oh, I'm going to let it compute. So it automatically moves back to where it originally was. I'm going to lock it so I don't have to worry about it messing around. And let's add all of these to this group we just made. It's a group. Okay. It should, yeah. Okay. So from here, let's unlock. We're going to let it compute, and it should allow us to see our working cell geometry a little bit higher. Not much of a difference, but if we wanted to raise it a lot, hopefully this doesn't crash, but we can actually see that it actually raises. And this does not affect our inputted base to our KUKA PRC core component. So yeah, now you can see it's actually moving through the table. This might be helpful if your base plane is a little bit higher, or if you actually wanted to maneuver your geometry in a different way. Let's say you have an actual box in the cell, and you actually want the cell and the robot to reflect correctly with the box being on the table. You can always offset it based on that height and move the box in that way. So yeah, this is, so let's say you had a box a certain height and you needed the actual working cell geometry to be lower. You can move it in that manner. There are plenty of ways to actually use this for setting up your working environment. Remove 0. And that's it.